Cominciamo?
Sì. Aquí, questo possiamo passarle.
Faccio timekeeping.
Cominciamo.
Sì.
Hello, good morning, everyone. So we are ready to start. So welcome to the CCAMP session here in IETF 119. So here in the room are Daniele, Whoop, Jaumian, and myself. And remotely, I think we have Fatai as well. So welcome from all of us. So let's see if it works. Okay. So as usual, we go through quickly through the note well. So for those participating in ITA, you need to be aware of the policies that apply to the meeting, the fact that everything which is here will be public, either in writing, audio, or video form, also photos, pictures, and also apply here the rules about the IPR. So be aware that whatever is discussed here should follow the rules of IPR in line with ITF global policies. Also relevant and important, the conduct guidelines. So this is a meeting where we need to behave with courtesy and respect to the colleagues in the discussion. So no personal discussions, everything keep on technical aspects. Regarding the meeting tips, be sure that you know well the tool for requesting to join the queue, to speak, and also to present if you want to activate your cameras. Or keep the audio and the video off if you are not if you are in you are not you are not in the queue. You don't need the need of intervening in the meeting, so that we can avoid disruptions for the normal running of the meeting. Well, more about the Meeteco details, the buttons that you have for joining the queue, and yeah, requesting the access remotely. You want to present the slides from home. There is the URL for the notes, ITA 119 CCAMP. Any volunteer is more than welcome for taking the notes. Make them collaboratively, because it's usually a hard task. So anyone that could help is very, very much welcome. For the blue sheets for recording, registering the participation in the meeting, please access the Meeteco. With that, we will have an automatic register of the ones participating in the process, in the meeting, sorry. So please do that. And just a reminder about the IPR process. So whatever is presented, commented, or discussed here is public. So and also whatever content that will be present in the draft. At the time of progress in the draft, we will run IPR. We will request the confirmation of any knowledge about the existing IPR. So yeah, be sure that you behave according to the policies in ITF. The session of today is last 2 hours. So the details are in the agenda. So let's go for the agenda, very packed agenda, as usual. So we will cover in the first part the working group documents, and in the last part, current activity, individual drafts that are being showing, let's say, the activity that we are running, basically. As a reminder, we would like to emphasize the need of using the mailing list. The mailing list is the venue where the consensus are reached among the participants in the working group. So please do so, and be sure that we use this channel for socializing, let's say, the advances on the work being done here. We would like to also emphasize the fact that now the majority of the work in the working group, let's say, is running on different calls in weekly or bi-weekly phases. So it's important to have the summary of this progress in the mailing list as well, and also the introduction of new topics and so we want to emphasize that, and also taking into consideration the activity in the mailing list for scheduling the next session. So yeah, basically bringing here to the meetings the work that is more active in the mailing list. For sure, Daniel, you want to?
No, this is a good point. We are probably the working group with the highest number of weekly calls, and that makes the most usage of GitHub, which is fine. You're absolutely free to work in the best way you see fit, but this shouldn't exclude discussions on the mailing list. So I don't know if you have open issues on GitHub. Everyone has access to it, but if you can bring them to the mailing list, it's probably easier to discuss and can reach a higher number of people.
Thank you. So again, the reminder about the IPR process, there will be polling as long as the documents are progressing. So we expect the answer for all the authors and contributors. So let's move now to the part of the working group status, where we are. So for this meeting, there was not any recent RFC. We have a document on the RFC editor's queue, which is the one about layer 1 types. And we have 3 other documents being processed by the ASG: the microwave topology, the layer 1 CSM, and the OTN topology YAM model. Apart from that, today we will cover some of the working group documents. They are listed in the agenda. So these 3: the optical impairment topology, the RSC 1993 bis, the WDM tunnel YANG, and the optical path computation YANG. So I think Scott is going to the queue.
Yeah, Scott Mansfield Erickson. Just back a page. I just want to make sure that I'm not missing something. But when I look at if you go back a page, can you go back a page? Yeah. On the microwave topology draft, it says it's waiting for something, but I don't think it's waiting for me. But if it is, then let me know. So it's not. So we're good?
No, I remember there's no action on you. No,
okay,
you're good,
perfect.
you're good.
Just wanted to make sure. Thanks.
Okay. For the documents that the working group documents which are not in the agenda, there is here a brief summary of the status. So for the YAN OTN slicing, there is no update since last IETF. There is here a dependency with a draft that is being moved forward in TIS. So depending on the progress of that draft, yeah, we can continue with the progress of this other draft here, or either clustering both or merging both. So it depends on the progress of the effort in this working group. For the OTN path computation YAN, no updates as well since last IETF meeting. So the draft is ready for working group last call after base path computation model is done in TIS working group. So we have this other dependency with the work in TIS. So as soon as we solve that, or the work is progressing there in TIS, can we move forward also this draft. So I think Naiwa wants to.
Yeah, just like to add quick comments to the OTN slicing updates. If you go back to the last page, yeah. So basically, we have this draft LU network slicing topology that was presented in TIS, and we had some positive feedback from the chairs after the meeting. Basically, it will likely get into the process. But also the feedback is we need to do some updates to the model, so to reflect why the reason why we are using this topology model instead of ACTMBN type 2. So once that reasoning is given, we will give another update of the draft, and then hopefully get this right into the working group process. Yeah.
Thank you. Then we have the draft on the Ethernet client TE topo YANG. No updates from last meeting, and next steps: alignment with packet T topology, alignment with the other topology models to support the multi-layer single instance topology, align with updates to the client signal model, and complete the model description. So a number of steps to be done yet. For the WDM IF LMP, the current version does not have any update regarding IETF 118, and there is the need to as next step some debate on how to progress the draft. For the DWDM IF Param Yang, the same story, the similar situation. Here there is a need for sync with the optical impairment draft and the RFC 1993 bis draft. So the idea would be to go to last call once the other two drafts are let's say, progressing in this last call as well. For the OTN tunnel model, no update from last ITF meeting. The draft will be ready for the working group last call after the T tunnel model is done in this working group. So again, a new dependency on the progress in this. And the next step will be working group last call. For the client signal Yang, the point here is to have more discussion on the draft, to yet keep working on that, and the authors will prepare a new version from Vancouver, basically, ITF 120. Apart from those drafts, there are 3 other drafts adopted by the working group with no further major updates. So we move to the next slide. Next slide is about the liaison statements. There are liaison statements related to CCAMP activity, the 3 that you can see there: the information model, data modeling coordination, the OTNT standardization work plan, and some information about the consented recommendations. So all of them, this is not the latest. Well,
It's not it.
yeah, we have not updated properly the slides, but the point is that 2 of them are informational, the first one and the third one, while the one in the middle requires some action. So this was raised by Deborah, but maybe Scott one.
Yeah, Scott Mansfield. The Deborah Bringard has sent out an email about the OTNT standardization work plan. So she's following up with that one. And so if there's anything, she'll probably write the thing and then send it around for review. For the IMDM, I said this in another meeting as well. The IMDM modeling coordination is for information, but it is a coordination meeting that the ITUT holds that invites other standards bodies. So if you're interested in Yang or information modeling or data modeling or whatever, we're working a lot right now on time synchronization modeling. So if you're interested in that, that's what's being discussed there. And then the other one is just consented recommendations. It's just a list of the work that was completed in the Yang area and the synchronization area from study group 15 at the last meeting. So thanks.
Thank you. And then the final slide for this deck. So just a report of the active calls that we are having in the working group. At least 7 of them: FlexiGrid, microwave, OTN slicing, optical pluggables, service pack computation, optical impairment, topology, and transport MBI. So this is the activity that between ITF meetings we are holding as a working group. So again, just let us reinforce the message that it would be nice to have some insight of the progress of this in the mailing list, so that all the working group could be aware of the progress, basically. And I think that was all from our side. You want to comment something else, Daniel? Okay, so we move to the first presentation.
We start with the first presentation. If I correctly remember, Sergio should be the speaker. Sergio?
Hello? Hello? Can you hear me?
Yes, perfectly.
Okay. So, hello everybody. Good morning to whom is in Australia, and good night or good evening for others. So I'm going to report the status of optical impairment aware topology Yang model on behalf of the co-authors and contributors of the drafts. Next. So what are the major updates since the last IETF? We made a lot of work to addressing some of the issue that was remaining. We added a young update and a text description for the modeling of multi-band and multi-stage cascaded amplifiers. We completed the dynamic gain equalizer model with the agreement to model the G function in different way with respect depending on the hardware implementation. So we basically model the DGE or as the 2-degree TN node that is terminating the OMS link, or as an amplifier element that is not terminating the OMS MCG. Then we introduce a template to describe the case in which there are optical impairments value in common between different systems, the same type of transceiver and ROADM. And then we fix some young model details. And okay, if you are interested in details, I report in the sub-bullets the details of what we made for young fixing. Next. So I mentioned before, so when it can happen that some impairments parameters value can be shared the same value between among the same type of ROADM or transceiver. And what happened is that you need to report for many instances of the same type for ROADM or transceiver, the same value of the parameters. So to avoid that, we added a template for this set of explicit parameters that are common at multiple elements. And this template obviously has to be referenced by ROADM or transceiver specific instance. Next. So here I reported an example for that. So as we added the template for both the ROADM impairments and the transceiver explicit parameters. So for example, for transceiver, on the left side of the slide, you have the list of explicit transceiver modes templates, and in the yellow one you have identifier of one particular list of parameters of value for the template, and on the right side in which there is the explicit mode description, you have the pointer to a specific template identifier that characterize the set of common value between many instances of the same element, transceiver elements. Next. Okay, I said we model in Young the multi-band multi-stage amplifier, and to support the modeling of multi-band and cascade amplifier, the OMS elements that describe the optical amplifier may contain an unordered list of amplifier elements. So we have, as reported in the picture, we have both the modeling of multiband and the cascade of the elements related to for the band C and band L. The OMS element that in case is the amplifier is modeled as an ordered list in which you have two parameters. You have the lower frequency and upper frequency that describing the frequency band the set of amplifier element are operating, and the parameters that reported the order in which in the sequential cascade the OMS the amplifier element is occupied the position in the cascade. On the right part of the slide, you can see the tree. So you have the amplifier element, so the unordered list of amplifier element, and you have the both the lower and upper frequency and the stage order for any of the amplifier element. And then you can have in the amplifier element, or it is a real amplifier or a DGA. In case of amplifier, you have specific mandatory attributes that are not in the case of dynamic gain equalizer. Next.
Sergio, you have a little bit less than 2 minutes and there's still a lot of slides. There is anything particular that you wanted to focus?
The next step for optical impairments. So basically, the draft is the Young model is stable, and for the draft side for the text, we have just a few sentences that are be more clarified to improve the all the content. So the draft will be ready for the working group last call as soon as this editorial work is done. But we know we have a dependency on RFC 1993 bis that is also in a good state. And so we think that the best things would be to have the working rulers call together. And a good candidate due to the status of the drafts would be the next IETF for 120. So this is for optical impairments.
Okay, let's go quickly. What do you want to cover in 8 seconds from the next presentation?
Okay, if we need to speed up, we just jump to the next step, because so we have work and we have closed almost all the technical open point from IETF 118. There is basically just one technical point that is still to discuss, and then there are some editorial work that is needed to complete from textual point of view. So we can be targeted to have be ready for working group last call for next IETF, and as said before, this can be a good success to report both 1993 optical impairments in the status for working group last call for next IETF.
Perfect. Thanks a lot. Yeah, I mean, the intention to move the two drafts together is there since the beginning. It makes a lot of sense, and thanks for moving them along together. Any other question from the floor, or we move to the next presentation?
Okay. Hi everyone. This is Iwa, and I'm presenting a next one. Oh, that's the wrong slides.
Probably we didn't get the synchronization. I'll share them.
Okay, can still control that, right?
I think so.
Okay. So again, this is Iwa, and I'm presenting here two drafts on behalf of the co-authors and contributors. The first one is the young data model for WDM tunnel. Next. No.
I see the full screen on my PC. I don't know why you can't there.
Oh. Maybe you can put it into presentation mode.
It is.
Oh, it is. Oh.
Which screen is which screen? Yeah, maybe it's a screen.
Right. Okay.
It's becoming too complex. I will move the slides for you.
Okay. So next slide. Yeah. So here's the brief updates since last IETF. So for this revision, we mainly focused on providing young model updates with only some cosmetic updates on the draft text, which will need to be done in the next revision. So on the young updates, what we did is we added the transceiver additional optional parameter under the transceiver constraints that can further provide the user an examples of constraint configuration. For example, the TX channel powers and the preferred X channel powers. So those constraints can be applied globally on a WDM tunnel scope, and also can be applied specifically to a source destination or S3R region nodes that are used by the tunnel. So we also synchronized with RFC 9093 BIS, pick up the updates by removing some obsolete parameters and the update of additional types definition for power parameters, etc. The also enhanced in the YAM model the description of the transceivers. That clarifies the use of those transceiver specification for both source destination and 3R region. And also the last is to synchronize with the latest IETF T tunnel model. Finally, given that the T model is in stable state, we brought the synchronization to with the latest version. And there are some compilation error fixes, etc. Next page. Right. So this is just an example of additional transceiver parameters that are applied to this model. Next page. Yeah. So the WDM label specification was picked up from 9093 BIS, which includes the a unified WDM label for both WSOund FlexGrid and applies to single or multi-carrier label. Next. Yeah, so a bunch of open issues. So first of all, the text, as we said, for this version only cosmetic updates, but the text actually will need some proper updates to align with the tunnel Young models. And also the second one is how do we model 3R regens? Because in the optical impairment model, there's already some structure with respect to the 3R. So we need to align the 3R modeling with optical impairment. And also another point is this model will intend to be used for support the tunnel provisioning for both integrated transponder, which is more quote unquote traditional, and also the remote transponders, for example, coherent pluggables. So hopefully the same model can be applied to cover both use cases. And the additional layer 0 attributes, in between layer 0 and layer 1 that is applicable to end-to-end tunnel provisioning would need to be taken into account. There's an open issue related to the boundary between layer 0 and layer 1, and which part of the layer 1 could be integrated into an end-to-end WDM tunnel provisioning. Yeah, so the next thing is also to reflect the relationship between the WDM tunnel and also the resulting OTSI or OTSIG objects when the WDM tunnel is provisioned. How do we show the relationship between these two? It's not currently reflected in the model. It needs to be added. Next page. Yeah, so the next step is just to address all those open issues that are mentioned in the last page. We also especially wanted to get some feedbacks from the working group and especially from the operators and those who implemented the model to make sure that there's no missing part towards the data model. And also some gap analysis in the context of pluggable use cases will be performed on this model. So we have the weekly meeting on every Thursday. So anyone interested in this work is more than welcome to join. Next page. Right. So before I go to the next one, any questions or comments? Okay, not
a very quick one on the previous. Actually, thinking of the pluggable work, the pluggables work, I thought that the optical impairments topology and the DWDM interface Young model would be impacted by that, and I didn't think of this one. So, thanks for considering it. What does it mean so are you planning to move forward independently from the pluggables work, or if there are anything that is needed that you are willing to wait for the requirements coming from there and address in the draft? What's the plan?
Well, I think the plan is to address the pluggables. Yeah, so definitely we need to check on it.
Okay.
Okay, so this second draft is the Young model for optical path computation. So a summary of the updates. We combined the Young model for path computation for WSON and flex grid and into this unified model. And it's the name of the model is changed to WDM path computation and obsolete the WSON and the flex grid path computation. The main updates of the model is just to align with the WDM tunnel Young and also use the same constructs for transceivers and 3Rs on one side, and the second point is to also align with 9093 BIS and pick up all the changes from the latest updates. and update with the base path path computation, which is also updated. So next page.
Sorry.
Yeah. So open issues. The name of the draft is currently optical path computation. What the authors are thinking is to change the name to instead WDM path computation to align with the also the WDM tunnel draft. And again, the same consideration, the intention of this model is to also be used as part of the MBI for both integrated transponder, local transponders, as well as remote transponders, especially in the pluggable scenario. Yeah, we need to do some gap analysis to cover all those scenarios. Next, yeah, next step. So currently, this draft has a limited number of co-authors and contributors. We are looking into the support for from a wider audience, especially from operators and other vendors. So we're gonna extend. We're open to welcome more co-authors of this draft. And the same thing, we will do gap analysis in the context of pluggable use cases. And this meeting is held also weekly along with the WDM tunnel. Yeah, question. I think that's it. Questions, comments? If you, Sergio, please.
Yes, I have a comment regarding what said before by Daniele regarding the impact of the model. So my view is that we have a good amount of work and layer 0 model, that is optical impairments, there is WDM tunnel, and 1993 bis, that is the base for both with common structure, and the interface model that has to be aligned with the new structure. So in my view, what the process is that is the pluggable that has to use what is already done in the CCAMP for layer 0, and if needed, has to add in his proper model what is needed. So this should be the process, not
It's
the impact
yes.
on the reverse. Yes.
Yep. Correct. Yeah. Good point. Transport NBI, who's presenting?
Thank you. Yeah, we are presenting, it's Italo Busi presenting for on behalf of the design team, a status update of what we are doing. So remind, what is the scope? We decided this design team has been chartered and created to discuss the use cases and the applicability of the young models at the northbound that are developed by the IETF and CCAMP in particular in the northbound interface of an optical domain controller, to see how it is possible to control the optical network resources using these models. The idea is to provide some guidelines to help people understanding how this model can be used together to solve some specific use cases that are applicable to transport network. And we agreed that, so we are going to work using a non-working group mailing list to have some discussion among the members, and we are publishing all our output using a GitHub, CCAMP GitHub, and the wiki. And everybody can join the design team at any time as they wish to contribute. We are also trying to provide also some JSON examples to describe specific use cases in details and trying to be agnostic to the deployed architecture. Okay, we have an open issue at this moment to describe what is exactly it is a transport MBI. So we need to decide. We have an initial text to describe what it is, and of course this is not completed. Any comment or input from the working group on the definition of what is a transparent API is welcome. We have a GitHub open issue where we are tracking this notice. And when we speak about well-defined, we also include not only the YAM model, but also the procedures. So how these YAM models are in the sequence that is needed to make sure that the service is set up, the resources are discovered, and so on.
This is sorry, Italo, this is a perfect example of a mail sent to the mailing list saying, "Hey, this is the text. What do you think?"
We will do that. Yeah. Okay. Yeah. Good question. Good point. And okay, and we are also trying to sync up and align the terminology we are using in this context with the terminology used in the IETF other contexts. So to have a consistent terminology, and also maybe some have some mapping or alignment with other work done outside of IETF. Okay, then we had some initial meetings and we published, we already done some work in Wiki GitHub, and we are discussing use cases and scenario. So a use case is typically a broader concept. We describe a set of component action and steps, but the scenario is a specific description of that. And we had an initial poll. There are a lot of use cases, a lot of scenarios to be analyzed in the context of transport network. So we decided to focus on few and to go into the details. And we found that the one that got most interest were inventory management in the context of transport network. So how we can use the IVI working group models to support transport network inventory management. And the second issue was how to describe and report multi-layer topology. The reason is that in the optical transport network, multi-layer is quite a normal practice, and we want to show how the IETF models can support a single instance multi-layer topology. And we are also trying to reuse some of the existing work that has been done in the context of 1.0, so the draft that we have already done in the previous years. Okay, then one of the, as I said, this is reporting what we did for the inventory. So for the inventory, we started with some use cases which were brought to the discussion also during the CCAMP working group work on inventory from Vodafone. So there are different type of equipment and examples of how the transport network equipment are built, and we wanted to show that the inventory YAM model is able to describe them. So, this is not the latest one. Okay. Sorry. Okay, so we have one example of an equipment, which is the one on the right, which is a multi-shelf equipment, but the shelf are spread over multiple racks. And that's a possibility. And the rack may be shared by multiple network elements. So one rack can contain shelves that belongs to different network elements. Or we can have also a case, which is the one on the left, where all the shelves in the network element belongs to the same network element. And we had a lot of discussion, and we agree that even in this case, the rack does never belongs to a network element. The network element starts from the shelf. And this is a particular configuration where all the shelves belongs to the same rack. Then we have other two interesting use cases where one is when the racks, the network element is spread over two rooms in the same site or even two sites. And we show that the YAM models that are in IVI can be used to support these use cases. Okay.
There is a question.
Is there a question? Maybe it's this one.
Yeah, hi, Swami, Nokia. So on the inventory, right? I mean, we had a discussion in the IV work group about, the planned and flat structure and everything, right?
This is only reporting what is installed. Good point.
Okay. So I mean, the point is that if the IV draft proceeds in the path, then all of this has to be reworked.
Yes. No. Well. It's always a subset. So the use case here is reporting what is installed.
Okay.
Then, if the IV do more, then we will say, okay, this is the subset of the IV that can be used to report what is installed, and then maybe we can add new use cases for more enhanced scenarios.
Okay. So the follow-up question is that the network element notion here, would it be the same definition as an IV where it's a collection of functions?
Yes.
Versus this
Yes.
is more.
Absolutely. Yes.
Okay. Thank you.
So just to emphasize that, we're intending to use the models as they're defined, and as they evolve, we have to evolve the descriptions here. So same applies to the network topology. So I've chosen a pictorial form to start with to try and get to grips with the actual layering and so on. So it's showing an RFC8345 pictorial view where we've got representations of the link, the brown lines, the termination point there, the purple things, and the nodes, the yellow things. And I've chosen a technique here which we've been using in TAPI, which has been quite beneficial to help us represent the networks. The reason I've chosen a pictorial view initially is that it helps get an understanding of the layering in general. And if you're familiar with some of the TAPI documentation, you'll find there are some very complex network pictures in that, which I don't fancy writing all the JSON for. So the idea here is we'd have maybe some modules of JSON which would represent particular pieces of this, and then we could show how they'd be assembled together to form the more complex networks. But starting with the pictorial view, and then my intention is to move on to JSON after this and get some JSON example fragments. And again, it's aligning this with the models that exist already. So it's just saying this is how you use them. Again, in the TAPI work, we found that to be extremely beneficial because it removes a lot of unnecessary variety in the way people represent things. So it gives us a lot more consistency in the way we see things being represented in the network in general. So next steps. GitHub for the activities. We have weekly meetings. We haven't got the times on this here, but we have weekly or bi-weekly meetings. Bi-weekly, thank you. Bi-weekly. They seem like they're weekly. No, it seems like they seem. It's just like they're so often. Yeah. Yes, that's right. So in the inventory model work, it was mentioned on the layering model. I've got to do quite a lot more work on alignment with the terminology. And getting the other models into play and looking at terminology across the industry, which led us to an idea that we might want to try and also explain relationships between our model work here and model work in other activities, so we can actually help people understand what we're doing and take it on board. So we've also, my point about JSON being extensive in some of the network situations, so looking at potentially tooling to help us generate the JSON. So it's not all done from scratch by hand, and also in general starting to publish the JSON. And we're looking to not produce a big monolith. The final slide here goes back to what Hill was saying about the existing work. One of the challenges with the existing work is it's huge, so it's difficult to penetrate and difficult to maintain and so on. So we're looking at putting together a more modular approach. Not going for a draft, but going for stuff on the wiki that becomes the guidance essentially in small units. But we are going to take samples out of this, so to extract, mine this to get text out of it and so on, and then put it into much more modular pieces. But on that basis, that's really essentially, I think, what we've got to say really today. So on the final thing there is. Working group chairs and any thoughts on this? Does that seem reasonable? Mine it and then break it up into smaller pieces to get around the challenge of getting the big monolith out in one go. And just to say, this is 95 pages. The TAPI equivalent.
Yeah, exactly.
The TAPI equivalent is 400 pages. So
so it's already good.
That's where this goes. I mean, so if you're not careful, we're gonna have to break that into pieces as well. So it's a nightmare to handle.
Probably it's more usable.
Yeah, in pieces. Yes, exactly. Okay. Any questions? Stop. Right. Stop.
I have a question.
Go ahead.
Come to the mic. John, I have a question for you. Sorry for the ambush. So we decided to put the result of this work into GitHub and into the wiki, because here we are not defining new models, protocols, extensions. So it's not something that we thought would go through the IETF process and be published as an RFC. However, I think this is something that is extremely useful because it teaches non-IETF experts how to use the models that we are defining. Moreover, there might be other standardization bodies interested in using these models, etc. So, is there a better way to make this work usable outside the IETF, like, I don't know, at a given point, draw a red line, publish it as an informational RFC, whatever.
I think practically speaking, informational RFC is really the answer. I mean, we could try other alternative publication methods, but I mean, you've already kind of ticked them off. And yeah, if we want to sort of draw a line under it, say this is, you know, in our opinion as a group of experts, the good advice at this point. Informational or BCP is the other thing in that category, but I think informational is like, I mean, informational is a lower bar publication.
BCP would be perfect. Would the SG be happy to?
I think so. We should sit down and just like double check the charter and make sure that it gives us, you know, space to propose that, and if not, we can roll that into a small update.
Okay,
but I think it's okay.
Yeah, I had one comment back on that. The one challenge I would have with the pictures is I don't know how to draw them in ASCII to the level I need to draw them. So if we can find some way of supporting that with pictorial stuff in a wiki, that would be important, I think.
We have fairly recently, I was going to say progressed, maybe it's still on an agenda, but at least one draft I can easily point to that only has the figures in SVG form in the HTML and PDF renderings.
Okay.
So I don't know if you have like any facility, I don't, with any of the SVG drawing tools, but we do have the ability at least to embed, you know, something
other
better
forms
than
of
ASCII.
Yeah, okay. 'Cause I'll show you one in a minute how big it is, and you'll see what I mean.
Okay.
I said the other day, it needs a double brontosaurus size page to get the ASCII on. So
yeah, I mean, you know,
it would be vast.
let's take it offline, but I can also show you like the other draft that I'm thinking of. We can maybe talk with the authors.
Yeah, my concern with the information receipt, we see with the first draft that we created is twofold. One is the graphically rich figures, which SVG, I think IETF SVG is still limited. And the second issue is the huge amount of information, a big document that we are going to produce, and that is also stuck in the current model. So maybe the solution, I think, is coming from Daniel to have maybe the big bunch of information in the wiki and maybe some summary in the information RFC, which points to the wiki, maybe a sort of compromise.
That's a good idea. I mean, it sounds like a good idea anyway.
Yeah, okay.
Like, what's the page count on this thing right now?
Sorry?
What's the page count right now?
It's 95, but as I said, the TAPI equivalent's 400, so we don't want to go there.
Okay.
Okay.
So in terms of the like creating a starting point so everybody understands what this TMBI is covering and what are data models are relevant to the TMBI, I would suggest we could consider like putting an like overview landscape of all the data models that have been created within IETF that are relevant to TMBI. Because a lot of times when we talk to people, like they just don't know the existence of IETF data models. So if we are pointing this, you know, just piece by piece, they may have difficulty trying to understand an overview picture.
You need an overview, and then so there's a way, and I fully agree with that. Yes, fully agree.
Regarding the future work about aligning the terms, I'm trying to understand how do we work on that, work on the other side or work on this side to make the terms of the two sides to be consistent, or just do a mapping?
So two things. I think that the mapping is important first of all because that's where we are. But I would personally try and work in other bodies that I'm in to improve the terminology alignment. So if you find a good term here, take it to that body and vice versa. So I think it would be, I mean, traditionally the bodies have all worked independently as if they all own everything and so on. It's much more sensible to try and collaborate across them. So if we can try and find a way of using this to help us normalize terminology in general across the industry, that would be useful, I think, as well. It's a long path, but
yeah, it's an important one.
You don't really have to try.
Yeah, the thing is that we need to be aligned also with the other work in IETF, so we cannot align with something external and then lose the alignment.
No, correct, exactly.
Okay.
It's IETF first, then external second.
Oscar, your
I
turn.
think if we have already a definition IETF, we can reuse it. If it's not, we can take it from elsewhere.
Oscar?
Yeah. So regarding the document that that Nigel was mentioning about the transport API, one of the useful things there was also have use cases solved. Okay. So here, not only examples, okay, but also this use case. So I don't know
I
if
think
you are
on the earlier slide,
considering.
we did say use case. The examples are basically related to use cases. It doesn't make sense, I think, just have examples in free form. You're quite right. So they have to be in the context of a use case.
Yeah.
Absolutely.
Yeah, do you remember in the WFI use case 1, 2, 3, 4, 5, 6, 7, we had a lot of those coming from operators, and then you have like solving. I don't know if you can do something also similar here beyond the examples. Yes. And then the next thing, also a question to or suggestion also to John is that whatever solution you find here for this work is also applicable for the general, for example, for the tunnel in general in IETF is the very same thing. It's no or T-topology, or there are a lot of things that how to use the junks are applicable in general. Okay, just to whatever you find the solution, apply it for all.
It applies to all Yang models across the board. I mean, the layer 3 DPM ones, etc. The whole lot would benefit from some guidelines on how to use them, having tried.
Yes. Yes, BCP or whatever it is, the BCP, if BCP is the way forward, let's do BCP.
So does this mean that you're volunteering to fully generalize the document to cover all of those technologies, or?
No. It's volunteers to help us generalize the suite of documents to fully cover all the.
Maybe we can give this an example of other groups, so now we can do that for other technologies. So if you want to show how to do that for layer 2, layer 3 VPN, it's better to have the layer 2, layer 3 VPN experts doing this work rather than us. But maybe they can follow the same guidelines.
We can collaborate.
Okay, so guys, I'm reluctant to cut off all these interesting discussions, but we are already late as usual. So for the next presenters, if you have 10 minutes, please try to keep the discussion limited to 8 so that we allow for some time for discussion. And the next is for...
Yep.
It's me. Okay. Okay, so I had 5 minutes. I'll try to stick to one. A little bit of introduction on the pluggables work and how it fits into the ACTN POI. So the ACTN POI is a work that is going on in TIS since a while. We have the step 1 here. You can see it in the slide. On the left, there is the step 2, which is mostly focused on service assurance. A while ago, we started this work in CCAMP, which was meant to be step 2B. Then there was a proliferation of documents with architectural discussion, etc., etc. We decided to stop completely that work and just focus on 2 documents, the ones that you can see below, and that will be presented immediately after this short intro. Basically, we grouped all the service providers, operators together, the ones interested in this work. They are working on delivering a document on network scenarios, use cases, and gap analysis within the ACTN framework. And this is the draft that Oscar will present now. Then we have put together all the vendors interested in this work, working on the modeling of coherent pluggables. The draft has not been published yet. You can see there is identified as draft 2B, but there is already a lot of work being done. And so hopefully it will be available soon. So this was just to give you an idea of what's happening. Because if you open up the CCAMP page, you might find 7, 8 drafts related to the pluggables. As of now, we are focusing just on these 2. Then once with this one will be delivered, we will open again the door to any other activity that anyone is willing to deliver, applicability documents, architecture documents, whatever it will come after. But as of now, we will work just on these 2. I hope it was quick enough. So now Oscar will present the first of the 2 documents.
Okay. So now, as Daniele mentioned, this document is now comes from a long history, and now it's a consensus where we got everyone together. So to go to the next page, we take a little bit the history. So as you know, the technology is mature enough. Okay, so here, especially for the 400 gig, now we have the CTAR Plus already in deployments, and it's ready to come in massive way to the operators. Okay, the 100 gig is a little bit yet to come this year. Okay, but I am pretty sure that it will end up coming. So we need to find solutions soon. So here, or the willingness of the operators is to have an end-to-end SDN control of this DWDM plugins, meaning that we wanted to be with a data model based. Okay, so we want to use the same young tooling that we are using in this. So here, as Daniele mentioned, this is a continuation of the work started in TIS for the general POI, but here just we have this what we call it multi-layer devices where IP and optical are together. So here, unfortunately, we spend a lot of time, a lot of discussions fighting on who control the pluggable. So whether it was the IP controller, it was the optical controller. So we decided to get away from that discussion. We acknowledge that there might be several ways of implementing, but independently on whether it is one particular piece or the other, the use cases are going to be the same, the data models are going to be the same, and all the machinery in the context of ICTN is going to be the same. So the details of whether it is one or the other, okay, we leave it to operator's choice to decide if go for one or other. So here we decided to get together and create this document on scenario use cases and scenarios and use cases, and then work in parallel with the modeling work. And now we started the first version, the operators together, to create these scenarios and use cases, and now we want to get everybody on board. Of course, I mean, we will have operators continuing to provide input, but it will go to go together. Okay. So here also we need to keep on aligning with this, because here is where the parent documents are, and also because, I mean, given it's a multi-layer IP MPLS over optical, and there will be multi-layer traffic engineering, I mean, it's good to be aligned with this. Okay, so you go to the next slide, please. No, next one, because you already discussed about this one. So here, just the 2 models of operation that we have. The traditional one is where the 2 networks were completely overlaid, and right now what we will have is really a mixed scenario where we will still have a lot of optical connections coming and ending in transponder or traditional muxponders, and there will be some other cases where we will have also coming directly from the packet devices. So this is where we are heading to. So next slide, please. So what are the 4 main scenarios that we are considering? I'm not saying that there might be some more corner cases, but this will be the more general one. The scenario A is the one that, let's say, just dark fiber between the the two pluggables. So in principle, there will be nothing to worry about. We don't need to fight with anyone sharing the infrastructure. In the second case, the scenario number B is where the fiber is shared, but only in a point-to-point fashion. So there is no mesh in between. And typically there will be from central office to central office, aggregating several traffic from several routers to the other place. So we need to fight only between ourselves. And then the scenario number C, which is we think is the most common one that we plan, is where we have a mesh, okay, and over that one we deploy the pluggable or the pluggable to pluggable connection. Scenario number D, it's gonna be not, I won't say corner case because we think it's reasonable that there will be, but in a more limited fashion, and especially now that with the 100 coming of the 100 gig coherent pluggables, that we will still have a lot legacy routers in a network. So we operators don't throw anything away. So it will be likely that there will be some new routers with the 100 gig pluggables there and connected to the other end with the traditional 100 gig transponder. Okay, so this is it will happen less, okay, but it's likely to happen. So next slide, please. So then what we did in the draft is to start sketching the use cases and compile them, prioritize them, and for each of the use cases we just identify whether it is for the general packet over optical case or it is the scenario just or for the particular case of the pluggable. So for us, it was a general agreement that the top priority was to have the full visibility. So we wanted to have the end-to-end visibility with all the layers, and precisely starting from the discovery and the inventory of the network of the devices and its layers. Okay, so within that, the first really sub use case is, okay, just what happens when you insert the pluggable, and then what happens? The device discovers it, makes the necessary relationships, etc. Then is the inventory of the pluggable, just anticipating any question, is after you have inserted it. Okay, so this is the use case where the targeting here, not before in the planning stage. That of course I agree, this will also need to happen, but the control plane will not be involved in that one. And then the discovery of the service itself. And then, of course, we need to be able to correlate the faults or the events that are happening, and also the performance to be able to correlate what happens at the optical and the IP layer. Then, and also within the sub-use cases, the one that is more interesting for the performance is just to be able to monitor the plug-to-plug connection the same way as any other traditional connection that you have in your network. So that it is, just because it's in a router, it should not be any different. Then we have the case of the inter-domain link validation. Says validation, so it's not discovery, okay? So the operators will document their network, and we can make mistakes, and all the time we make mistakes. So it's just validation, it's verification. And then the use case is just in the last case for the provisioning, starting from the solutioning from plug to plug, and then having the end-to-end, okay, coordinating with triggered by a service, by a VPN, slice, or whatever it is, just regular or with optical restoration. So if you go to the next slide, we end here. So here what we seek is feedback from the working group, get reviews of the draft, and provide more use cases. We keep the alignment with the parent drafts, work together with the terminology, and improve the draft. So I think we should be able to. I think that at least the good thing is that I think there is consensus among the people working here, and let's say that we don't have now. We are working together in this. So, any questions, suggestions?
No, thanks a lot for the draft because it's cleaning up a little bit the mess that we had on requirements, use cases. So we will use this as the Bible to move forward with the work. Reza. Let me reset the timer. And thanks a lot for the 50 seconds back.
Good morning, everyone. My name is Reza Rokwi from Siena. As you see here, on behalf of all the co-authors and contributor, I'm going to discuss the modeling of the pluggable, the work that we started a few months ago. As Daniel and Oscar mentioned, so this is complementing the area for the use cases and the scenarios that Oscar have. This work is basically complementing the overall structure of the pluggable when we want to use the existing model that we have, not only at IETF, but other STOs. As I go through this presentation, we want to make sure that we consider all the resources that we have for the modeling. We are not going to reinvent the wheel. We are going to reuse existing models that is there. And if there is anything that we want to address as gap analysis, this is the best opportunity for us to address it, considering all the document that we are looking at right now. So from the pluggable perspective, if you look at the green boxes only, the first question that people might ask, the model that we are referring here is a network model or device model. And this is an important aspect to consider, that we feel that this is the both device model and network model is addressing both. In most cases, they are the same, but we are open-minded about that. If there is, as we go progress, if there is a device model and the network model, there are the 90-10%, 90% that the same, 10% different, or so forth. We want to make sure that we are addressing that. We address this one as we go forward, and we learn whether or not they are 100% the same or there are some differences. But this is at least the first starting point that we've done. And as you see on the left-hand side, the second box, yellow, it says we are going to use existing STOs. Definitely IETF is the very first one that we address, and all the draft that you've seen today will be the basis: impairment, DWDM, tunnel, and layer 0 service, layer 0 yank types, and everything. We went through all those and try to use all the existing one. We find out there are lots of inconsistency, lots of duplication and changes, but these are the whole idea, to use existing model, and we present that one as we go forward. And we are not only using IETF as a resource, we are going to use others as well. We are going to use OpenConfig, ITUT, OIF, and so forth. The model that they have, this is giving us the opportunity to not only focus on the IETF, but others, if they are having something which is complementing our work, we are going to use them, and we are going to address it as we go through the discussion. The red one also is very important here at the bottom right of this picture, which is out of scope. Something internal to the router, when we do the plug and everything related to that, at least is out of scope for phase one. We call this one phase one. But as we go forward, if there is a phase two and we want to do that one and the mapping that happens between this model, we feel that it's important as well for the full end-to-end the use cases. When you put the plug internal to the router or the host, not only the router, the host could be any devices. That is something that we also should consider. At least for now, we consider the phase two, and as we go through the phase one, we learn more at which point we have to address it and to which extent. With that one in mind, the first item that it shows here as a generic representation of the plug, it has two sides, two personality. One side on the left-hand side, which is connected to the host, is electrical side, the characteristic of those attributes, which on the left-hand side, most likely host or router should be aware of majority of them, or at least a subset of them. This is something that both should agree on those. On the right-hand side, however, there are some characteristics from optical and photonic, and in most cases, host or router should not be concerned about those. Again, I will say majority, in most cases, we find out 100% the case, but we want to just keep that one in mind, that if there are some of those attributes that hosts should be aware, we will consider that one as well. So the former, we call it host interfaces, and the latter case, we call it media interface. Having this one in mind, we want item number 2 here says that we are going to focus on the various areas. And these various areas is also explained here, that we are talking about from the modeling perspective, the capability. These are the read-only hardware or software characteristic that a specific hardware pluggable can support. You cannot change that. This is a characteristic of that plug. We have to have those capabilities. We call it capability. There are configuration, read-write, that you have to configure. You have to configure which modulation you want to use. The pluggable can support 5 different modulation, but you want to use one of them, or the power and central frequency, another thing. At the same time, this configuration has different personality as well. One is configuration of the plug itself. Another one that we are investigating now is related to the state and the threshold that we want to consider. For example, if I want to have a generic approach for a state to have some threshold, we have to configure something. And we are trying to find out a way with existing IETF model from the Yang push or other notification, whether or not we can use those mechanisms as the generic thing, not very specific to any attribute per se, but this is another thing we want to do. And last but not least, read-only state. That in most cases, these states are time varying. In other words, maybe all of them or majority of them have the characteristic of the minimum, maximum, average, the instantaneous value, and so forth. So again, we have to have a mechanism to address that one as a generic approach. This is the mindset that we are going after. And with that one, we created, for the sake of the sharing, we created a Google Sheet. This is a sample of that. It's an older one. The newer one is different a bit. But the idea here is everybody can contribute. Everybody can go to the Google Sheet and change. Just put your name and say why you are changing something. And the whole idea here is to make sure there is 100% transparency, and everybody can contribute as we go forward. And if you are interested to be part of this, let me know. I can add you to that Google Sheet. Right now we have around 20 people can access this one and can modify it, and everybody is more than welcome to join this activity. The more the better, but it's very important to have that mindset. And as we go through a bit detail, I don't want to go and bore you with the attributes that we want to address, but the attributes these are just sample of that. It's not the complete list, but to give you just a glimpse of what are those categories. We try to, as we go through this exercise, categorize the attribute instead of having a linear list of attributes, giving a context. Some of the attributes are FEC related, some of them are power related, some of them are modulation related, and so forth. And this is the idea that we want to address here. And as we go through this exercise, we learn more which one should be, and some of the attributes have 2 personality, and which one you put where, and this is the thing that we are doing. Another the challenge that we have, and we find out and mentioned it implicitly before, about the naming. Some of the attributes name that we find at IETF various documents or other STOs that I mentioned before, the naming is not. For example, chromatic dispersion, this is a very favorite attribute for Nigel. Sometimes they call it CD. Sometimes they do it something. These are things that there is a maximum minimum. Sometimes they put mean at the beginning, sometimes at the end, sometimes output is transmit or input is, those type of things that we find out, and we have to have a common idea for us, what's the best way to do it, and we go through that one. And we do some of the thing that you see here. If we choose some of the property from other SDOs, we have to do the validity here as well. But anyway, this is the naming convention and property. This is one thing that we have to do. From the next step, I mentioned a couple of times, we're now going through all those attributes from the first part is the optical and coherent properties. I mentioned to you before, there are host side as well, but we just started with this one. This is something that if you heard, for example, operational mode in OpenConfig or other STOs, these are the attributes which are majority capability. We started with that, and after that we go through the host side, we continue with the capability. And I mentioned the number 4 here, the mechanism to have a threshold, a generic approach to find out how we can put some threshold watermark for the minimum, maximum, and so forth for attribute. And last but not least, we have to also consider the proprietary property that an attribute which exists. Like it or not, this is something that will be, and what is the best way to address it. So with that, I think that we are open for questions, if there are any.
Reza, before going to the questions, one quick comment about the Google Sheet and all these kind of external tools. Probably would be convenient to put in the wiki some entry to reference in the Google Sheet and probably how to access that and so.
Yeah,
okay.
Sure, definitely.
Feel free to take all the time that you want.
Yeah. I will speak and run. 好评华为 what's my question? Oh, thank you, and I really appreciate the comprehensive slides and to harmonize with all other organizations and open it up to a joint contribution by sharing a spreadsheet. But regarding the next phase of work about the host characteristics, I'm just trying to make sure that it can be a kind of generalized host, not only restricted to router or whatever, right?
Yeah, definitely. I mentioned host could be anything, but again, this is a golden opportunity for everyone to contribute. If there is something that you want to have, please. Italo, please.
Yes, just a suggestion. I see that you have some concern with the naming of the attribute, but it will be good when we go to the gaps to identify what is a real gap, or something which is missing. Because I think if an attribute is missing, is much worse issue than having a name that has to be improved.
Definitely. So this is about
good
just
to give the right weight to the different issues that we identify.
Just bringing that awareness to everyone, this exists. Whether or not it's important or how important it is, I agree with you. Okay, thank you very much, everyone.
Okay, 12 minutes behind. Chode, now you have 2 slots. If you can try to squeeze a little bit things, that would be appreciated.
I will try my best. Okay. Hi everyone, this is Chode from Huawei. I'm glad to do the presentation on behalf of all the co-authors. Next slide, please. Okay. At first, let's recap the status of this draft. And this draft aims to cover the functionality of MTOC performance management interface. And currently, all the necessary interface have been covered by this draft. So for the content and the young data model, there's not too much to update right now. And to be noticed that this draft can be harmonized with the existing IETF data model, and it will fill up the gaps of performance monitoring of ASIN interface. And next slide, please. And for this version, what we have update mainly focus on the use cases and example in the appendix, and including how to get the performance monitoring capability of a specific resource and creating or delete a performance monitoring task. And with this performance monitoring task, we can get the current and historical history performance monitoring data or resource. And also we have a series of use cases and example design for the threshold crossing alert, including create a TCA profile and get the profiles information, and also how to configure the TCA on the resource, and also the notification of a threshold crossing alert. And we also can get all the resources associated with a TCA profile. Okay, next slide, please. Since these jobs have been presented several times in CCAMP and most of the content is stable right now, we believe it's time for the working group adoption. And just like what we said, this draft have filled out the gaps of performance monitoring for HTN. And we also consider if this draft can be adopted by the working group, it will be helpful to contribute to the TNBI design team in the future. And we also consider that maybe we still need to have some collaborate with the service PM draft. Okay, that's all for the presentation for this draft. Okay, any question for this?
I was planning to run a share of answer, but we will take it to the list because we are really running out of time. But
can you go?
We will consider the adoption.
Okay, can we go to the service PM first, because the service PM job slide is much related with the discussion of the last topic. Okay, for the service PM job, we have made these updates since last IETF meeting, and these updates are made mainly made on the content of the document. The first update we give to more discussion on the relationship between the article resource PM draft, and for these two drafts, they are operating in different levels. The object operated by the service PM draft is the network level, while the optical resource PM are operated on the device level. The resource PM aim to cover the traditional performance monitoring approach, while the service PM aim to provide a more user-oriented performance monitoring data. The data of the service performance monitoring data could be collected from or calculated by this the resource PM data. And we also introduced two use cases for service PM. One is automatic service acceptance test, and one is private line service SLA assurance. These two use cases will be introduced on detail in the next slide. And we also update the section of parameter consideration, and we give some explanation how to use the data model to do the service latency measurement. Okay, next slide. And for the new use case we introduced in this version, use case one is service acceptance test. As before, after the service is provisioned, engineers need to go to on-site and validate the status of service, whether it is reachable or not. And that is called acceptance test. Usually they need to take some device such as a tester to test the traffic and send the traffic from the source node and check whether the traffic has been received on the destination. It means that if there's no issues, and then the acceptance test is finished, and then the service could be delivered to the users. And this approach needs two engineers to cooperate, and it is human intensive, and it will take more time to bring the service to market. And we consider with the help of service PM model, the app system could test the service performance data automatically, and they can run the service latency test instead of the traffic test to check whether the service is reachable or not from the source to destination, and people are not needed to go on site. And the second use case is private line service SLA assurance. Once the service performance data could be provided by the domain controls northbound, and not only the OSS could use this data, but also the application of user can get this data. as we know, it's very expensive to buy the private line service, and for different people, they have different requirement for the service. For example, some user have value a lot on the latency, and some people value a lot on the bandwidth, and some people value a lot on the availability. And usually, there will be a service level agreement signed by the operator and the user to guarantee that the operator could provide the service SLA to the user to satisfy their requirement. To make this SLA visible, the operator need to provide the application to allow the user to monitor the SLA value in any time. And also for the operator, they also have got some demand to monitor their service performance data to do proactive maintenance before the SLA violation. Next slide, please. And for the service latency measurement, there has been a standard defined in IETF 709, in which it describes how to utilize the DMP overhead to test the latency value. These tests could be used to test the latency of a link, and also could be used to test the latency of pass. The measurement mechanism could be simply summarized as the latency is calculated by the series of overhead sending from the sending and collection time by the 0-1 transmission transition of the overhead. This mechanism, in this measurement, the destination should be looped back at first before the overhead sending from the source side. And for the single domain service, the domain controller can do the orchestration and decide which end is source and which end is destination. However, and for the multi-domain service, an orchestrator is needed to do the orchestration, and the orchestrator need to determine which end is the source and which end is the destination. And different commands will be sent to different domains, so that it will guarantee that the latency could be measured successfully. So in this data model, a measure method attribute is used to indicate these different commands for the source and destination latency measurement. Okay, next slide, please. For the next step, we believe that we still need to define more service level performance monitoring parameter and determine how to do the measurement mechanism. And also we consider we need to collaborate with the optical resource PM draft. One more thing we want to remind that is we still remind to the working group is, in last year's Yokohama's meeting, there's actually is a polling to check whether it should be adopted by the working group, and most of the people agreed to adopt this draft as working group document. But there's not a formal email in the mailing list to adopt this draft, and now 1 year has been passed, and we don't know whether there could be anything changed or to brought this draft to be adopted by the working group. Okay, sounds. That's all for the presentation for this draft. Okay. For this draft, provide two extension model to augmenting to TE topology and TE tunnel model. They should be used in the northbound of the main controller. Next slide, please. For the motivation of this draft, compared with the traditional interface such as XML and CORBA, AC interface has got some advantage on the service of abstraction. It can facilitate the simplification of network configuration. And but the disadvantage of ACN interface is it is lacking of full lifecycle network management. the discussion of maintenance interface is not too much in IETF. So the first motivation of this draft is to seek out a way to support FCAP's interface. Domain controller is a part of a network management system, and there could be some OSS and BSS above it. And this system has integrated with some traditional interface. The mainstream interface is XML and COBA. And as a newcomer, ASN, if it want to replace the interface adopted in the live network, we need to support the existing functionality integrated in the network so that it is a backwards compatible change for the upper system. And to better inherit the functionality of traditional interface, we think that we need to align the model of ASTN and TMF. The functionality could be reflected by the object provided by the model, but also the attribute for each object. Another motivation of this draft is to eliminate the debate between ASTN and TAPI. We also would like to align the modeling of ASTN and TAPI so that when orchestrator, when they are integrating with these two interfaces, they could have unified functionality through different models. The last motivation of this draft is we would like to improve the ease of integration of ASTN. When RESTCOM interface have been integrated in the lineup, a critical issue is there's not a mature solution to deal with the scalability issue, especially in large network. And when physical resources are supporting hundreds of logical resources, it's important to deal with the life cycle of this logical resource. Next slide, please.
Xavier, there is a question from Nigel.
Okay.
Nigel Davis, Sienna. It's on this slide. So when you say traditional TMF, I've got two questions, actually, 2 points. When you say traditional TMF, what did you mean specifically? Did you mean MTOSI, or were you going as far as the SID or ETOM, or how much of TMF were you thinking?
The scope including the MTOSI and also the COBA interface. And to be specific,
so okay, that's fine. That's fine. That's because TMF's got quite a broad suite of stuff. I just wondered how far you were thinking. And on the TAPI alignment, I'd be very keen to help on that if you want. We can talk on that offline and see how we can proceed with that.
Okay, thank you. Yeah. Okay, next slide. To how to support FCAS by ASN interface, we consider there could be two options. The first option is to rebuild a new series of FCAS interface. The second option is to inherit the existing interface. For the first option, what the potential implication is, we need to do some new research on the device, which is similar to the role played by the IGUTG A74 and A75, etc. For example, if we need to know how the alarm is generated on ASN on the ASN object, and how the indicators are defined for performance monitoring, there could be several examples for this option. And one is the service P, and another one is instance management. Because a new series of interface, there's no, it is a new series interface. There is no history burden for this operation and for this option. And
Xiaode, sorry.
Yeah.
For the interruption, you only have 1 minute more, so less than 1 minute.
Oh, okay.
So please.
And maybe I can go for it. Yeah. Okay. Some better design could be introduced for option 1. And for option 2, the second option is to inherit the functionality of traditional interface, and the alarm generation and performance monitoring mechanism have been studied before. And so that we consider the existing research of FCAS are mature and there is no theoretical defeat. And it is also easier to integrate with the traditional ARP system, just like what I mentioned in last slide. For example, the system have to integrate with the traditional interface. And for the
Shall please, can you wrap up, please?
Okay. Maybe next slide. Okay, for the modeling of ASIN, according to last slide, we can see that if we need to go to the option 2, we need to align the ASIN model object to the TMF object. And the table on the left is our consideration how could the ASIN object could map to the TMF model. Okay, next slide, please. But it is not enough to have a one-to-one mapping from the ASIN object, but also we need to confirm whether the attribute for each object have been covered by the ASIN interface, so that there could be some extension on the current data model. Here is our proposal how to do the extension. We propose for the current ASIN data model, they can keep pushing forward. But for this part of extension, we can, for this part of extension, it should be optional, and we can run it parallelly. So for the next step, we want to investigate whether we could what would be extended for the T topology model and T-tunnel model, and we also need to investigate what would be the technology specific extension. And also we want welcome people to join this work. Okay, thanks. That's all for the presentation today.
Thank you. There are no time for comments, so we will take it in the list. Thank you.
Okay.
Next presenter. Okay, so a quick time check. We have 20 minutes left, 3 presentations. So I will set the timer to 7 minutes each. Please, guys, try to stay within the time.
Okay, thank you, Mr. Chairman. This draft, the authors from China Mobile and Huawei. This draft is about past computation extension requirements for the new technology for granularity transport network. Next slide, please. Here we give the introduction for the background. With the proposal of new service development, the transport technology includes the optical transport network and metro transport network are both moving towards a fine-grained bandwidth hard slices. That means the smallest granularity for the TDM time slot is moving towards the smaller granularity. ITOT has started a series of recommendations for FGOTN, the fine-grained OTN, and FGMTN, fine-grained MTN. This document focuses on the requirements. We think that the path computation and control protocols for the fine-grained transport network needs to be extended for the new requirements. We have presented this document in the last meeting in the PCE working group, and this time presented again at CCAMP group. We hope to focus on the FGOT and FGMTN standard processes and requirements. Thank you. Next slide. First, why we need the fine-grained transport network. Some vertical industries and dedicated light service customers, they have higher requirements on the hard isolation, but their bandwidth is smaller. So the fine-grained TDM technology can provide the flexible bandwidth. The smallest, the finest bandwidth is 10 megabits. They provide these hard pipes for the customers for their connection. ITOT has a series of recommendations for FGOT and FGMT, and the some recommendations have been consulted. For example, the overview recommendations, architecture, and the interface, including the structure for the TDM frames. So for the future massive fine-grained transport connections, how to extensively perform end-to-end parse computation and control will be a very important topic. Next slide, please. We think the fine-grained transport path computation requirements has some new features compared to traditional hard pipes. For example, the number of fine-grained TDM channels will significantly increase compared to the traditional connections. For example, for the OTN, the audio 2 channel can support more than 900 FG-OTN connections. For the MTN channel, the 5 gigabit channel can support up to 480 FG-MTN connections. That means in the network, in the core layer 1 device, that switching capability is more than 10 terabits. That means one device can support tens of thousands of fine-grained channel connections. That way will bring great challenges for the path computation and control. Next slide, please. Another feature is that according to the service requirements, fine-grained paths may change frequently and dynamically. Since one fine-grained channel can carry and corresponding a certain CBR or Ethernet service. When the services appear or end, or its bandwidth changes, or the destination address changes, all the reasons will cause changes in the fine-grained channels. We need to set up or change the existing connections. So compared with the traditional optical network, the fine-grained transport networks requires a large number, the faster and more flexible path setup and removing capabilities. So we think the centralized computation model of PCE seems to be suitable for the new requirement. Next slide, please. The use cases and functions of fine-grained path computation include the fine-grained path setup, resource management, path update, path removing, and service awareness and mapping at the PE nodes. Next slide, please. So including, we think that control protocols need to be extended to meet the new requirement. For example, the path computation request and reply message must contain the new information. For example, the fine-grained switching capability type, the fine-grained server layer type, the time slot, the fine-grained client ID, or end-to-end fine-grained granularity path protection type. So the protocol and signaling should support the new application and to extend the protocol. Next slide. This draft mainly proposed the requirements. The specific extensions may be provided in the future. Draft comments welcome. Thank you.
Thanks a lot for shortening the presentation. We will take the comments.
Yeah, Xiaomi from ZTE. As far as I know, in ITUT SG15, they have consented some recommendations for the FGMTN and FGOTN, and they are defined as a separate network. So CCAMP working group, as I know, has traditionally working on some control plane work and model for transport networks. So it seems to me reasonable for CCAMP to take on this work. So that's my 2 cents.
Okay, thank you. Thanks a lot. Please.
Yeah, hello, hello, Chair. So can you hear me clear?
Perfectly.
Yeah.
Okay, so this is E from Huawei, and this draft is about the applicability of GMPRs for the fine-grained OTN. So it's, of course, related to the previous contribution. And this is it to present on behalf of all the authors. So next, please. And this page gives a high-level overview of the FGOTN standards. So as we know, ITU has already consented the FGOTN related standards, including the G.709.20 and G.709, new version of G.709. And in that, in the FGOTN standards, a new tributary slot type with 10 megabit per second is introduced, and sub-1G client signals can be carried by the FG audio flashes connection, and the FG OTN connection can be multiplexed into the audio J with the fine-grained tributary slots. Here, the audio J could be the audio 0, audio 1, audio 2, or audio flash, which has a lower bit rate than the audio 2. So the total number of the FG tributary slot of an audio J could be from 1 time of 119 to 8 times of 119. And one audio FG audio connection, one FG audio flash can occupy maybe 1 to 119 tributary slots in an audio J. And for the second step, if we put the audio J into the audio K, it's actually the same as a traditional OTN. So it means that we can use the traditional 1.25 giga or 2.5 giga tributary slot to map into the audio K. So this is the high-level overview of FGOTN. So next, please. And this page provides some typical scenarios of FGOTN. So the first one is about the point-to-point private line services. So the FGOTN can be used for the private line service as an alternative solution for the SDH. And this use case is actually described in the ITUT standards. And so in that case, the FGOTN connection may go through the metro OTN metro network and also the backbone network. And the second use case is about the multi-point to multi-point private network services. And in this case, the FGOTN can be used to provide multi-point to multi-point connectivities for the customers. So if the customer have multiple branches and the customer want to connect to multiple data centers, then they may need multiple fine-grained OTN connections to connect all these sites together and to form the virtual network. So this case is also described in another draft about the optical to cloud draft. So next, please. So here we provide some analysis on the gap analysis for the GMPRs for FGOTN. So of course, for the connection control, we need the new signal type, new tributary slot, and new FGOTN labels, etc. And the most important point is that we need to consider the scalability of the connection control. So as we said, the OTN may have thousands of connections in one audio 4 connection. So the scalability consideration is important, especially for the routing. Next one, please. So another point is about the service control. So as we mentioned, for the multi-point to multi-point services, the OTN edge node, for example, the OE1, it need to map different service flows into different OTN connections. And this means that the OE1 needs to know that the green packet is going to the data center A, and the orange packet is going to the data center B. So this means the OE1 need to know the connection relationship between the data center and the OE3 and OE4. So we may need to introduce a new protocols to support this kind of service address learning. Next one, please. And for the routing consideration, since that the OTN CPE may be at the edge of the metro network, so the OTN network may covers a much larger scope of the network, including the customer side, the metro access network, metro aggregation network, and metro core, and even a backbone OTN network. So it means that the scalability of the routing protocols need to be carefully considered. Next one, please. So in the next step, we'll do more detailed research on the gap analysis to use GMPS for the FG OTN, including traditional GMPS and also the PCE protocols. And we will also start the related protocol design and collaborating with other jobs, including the previous job presented by Liu Yan. And also the comments are always welcome, and we are open to all the aspects if you are interested in these topics. So thank you.
Thanks a lot. While I bring it's funny that we move from beyond the 400 giga to cutting O2 into 119 pieces. Someone in ITU has serious problems with packets.
That's right. Well, now for something completely different. And so this is a very quick update. I'm not going to take a lot of time on this one. You've heard about this before. It's an individual draft. We're trying to do a BIS of the microwave radio link. So we have weekly conference calls for an hour where we discuss these things, and there's a GitHub. So feel free to join the GitHub, do that. And we've heard what the chairs have said about sharing the information, not just on the GitHub, but also sending the meeting minutes and out onto the mailing list so that people see the work moving forward. So we'll take that on and do that as well. What we need to do now is to finish our gap analysis that we're doing between the microwave work in Etsy and in OpenConfig and other places with what's in 8561. There seems to be people that are very interested, companies, service providers that would like to have an IETF microwave radio link draft that did what they needed so they don't have to go to other places to get the microwave yang. So we have a bunch of open discussions. This is a list of the things that are open, and there's links to each of I won't go into these because we don't have time, but you click on these and you can go and see what the discussion has been about these particular topics. And we're going to ask for more conference calls. So if there's anything you guys need to do to set up the WebEx, whatever it is, we'll ask for that so that we can continue our weekly meetings. And then I would like to, at some point between now and the next IETF, to get to a point on the mailing list where we could get working group adoption, at least a consideration of that. So that's it.
Now I feel guilty because we are 3 minutes behind. Thanks a lot. So thanks a lot to the last 3 presenters. Excellent job. If there is no question, maybe we can let our friends in Europe and US go to bed a little bit, 2 minutes before expected. Thank you, everyone. Thanks a lot.
Thank you. Bye-bye.
Bye. Sorpresa, eravamo tipo 15 minuti in ritardo.
Poi
Abbiamo recuperato. Ma è stata la foto che ha fatto
sì. Sono così spaventati.
Segui un po' il calcio, lo sai chi era quello? Quello della foto?
Il Delegador, no, ¿cómo se dice?